Hi. Hi. Good afternoon, everyone. So, thank you for being here in the afternoon. So, just to level set, who has come to our meetup before? Out of the box network developers? Okay, a few. For others, so those who have come before know me. I'm Sujata Tubriwala. For others, I'm Sujata Tubriwala, Community Development Manager for Networking here at Intel. So my work involves working with developers outside of Intel in the networking, SDN and NFV area to enable them to work in whatever project they're doing. I know it's a huge umbrella, SDN and NFV. So there are several things that we do in this area. So on the bottom right you see, or the bottom left you see a snapshot of Intel Developer Zone. We have multiple technologies that we talk about there. That's expansion, the bubbles that you see there. We have code samples, video tutorials, and we also have a developer forum there for you to ask questions and answers. We do live trainings throughout of the box network developers. This is our Santa Clara meetup. Other than Santa Clara, we have meetups in Bangalore. We are starting one in April in London. We had one in Dublin, and we're starting in China as well. And apart from that, we would like to help individual developers through a program that we call Intel Software Innovators. So if you need support from us, you need hardware access, you need engineering support, or anything get the word out about the project that you're working on, please come and reach me and I can help you with that. So here is a snapshot of what we did in 2017. The community is growing. We are 2,000 plus members worldwide now. In 2017, we had we trained over 6,000 developers in events like this. So these are developers who are trained live in 15 events. So this included 19 network innovators who trained 4,000 developers. So they went to conferences and events like that and talked about the projects that they are working on, and we enabled that. So with that, this is today's agenda. We have a packed agenda. I hope you've seen that, and that's why you're here, right? So before we go into the agenda, there are some housekeeping things. If you have not already, please silence your cell phones. The second and important thing is, if you have any questions, please raise your hand. We will get a microphone to you because we are recording all the sessions and they're also live streamed, so it helps with that. Wi-Fi information: if you did not get the Wi-Fi on your way in, here is how you get connected to the Wi-Fi. And last but not the least, we want to hear from you what you thought about these sessions, what you want to hear more from us. So on your way out, please complete the surveys. And what you see on this slide are some of the goodies that you will get. We'll raffle these goodies to whoever do the survey. So with that, I will hand over the mic to Brian Johnson. He will be talking about enabling new protocol processing with DPDK using Dynamic Device Personalization. So he's a solution architect for Intel Ethernet products, focusing on network packet processing, virtualization, and NFV technologies. He's responsible for the definition and development of networking best practices for cloud and NFVI deployment technologies. He has over 20 years of experience in server and network product planning, during which he held various positions in strategic planning, technical product marketing, and product development. So, Brian.
Thanks. And we're
going
to have to
one question. So there are 3 tracks, right? So that we have different rooms for them?
Yeah, so we have dividers here.
Oh, okay.
And I need a second because I have to add a microphone. Have the
I think you need 2 mics, one for the...
No, I got one on.
Oh, you got one.
Yep. Okay. And I'm going to switch out. Okay. How you guys doing? So this is my first DPDK meetup, so not quite sure what kind of questions to expect, but please ask them, and we'll kind of go from there. You can ask, mid-presentation. I'll try to remember to repeat if you don't have a microphone, but ideally we get a microphone so they can hear it on the recording. So I am Brian Johnson. I'm a solutions architect in the networking division. Focused a lot on virtualization in the first part of my career, and then moved into NFV and SDN and all the new stuff over the last 3 or 4 years. And the last couple of years been working very closely with the DPDK team on enabling our network adapters and network controllers within DPDK. Here's all the legal stuff we have to put up. So quick agenda, problem statement. What are some of the capabilities on the controller that I'll talk about that has this new capability called Dynamic Device Personalization? How it gets programmed, examples, and then how to use it within DPDK. Okay? So when we were just working within the enterprise, the number of protocols that we had to support was pretty limited. Now, as we're moving into the telecommunication, cloud, that has grown exponentially from our standpoint. Not from the comm standpoint. A lot of these have been around for a number of years, but we didn't really have to worry about accelerating them or getting really high line rate and packet throughput on traditional network controllers, because they were used or they were being processed by dedicated appliances. Now, as NFV, you have to, 1, do it on Xeon cores, and 2, take care of it as much as possible within the network controller and so forth. So as you look at all the different orange and red protocols, those are ones that our network controllers typically don't support out of the box. So as we started working within the 5G, on the edge, having to support like GTP, PPPoE, and even custom VXLAN, VXLAN GPE additional protocols, we realized that our controller that we had some programmability in wasn't going to be able to support all of these protocols concurrently. And not all of those protocols really needed to be supported on the same device at the same time. We have the primary ones, those are by default, and then we had to figure out some way of adding these additional protocols when required. So we've been working with our 700 series products and taking advantage of some of the programmability that we built into it to be able to add this functionality. So why is this important? Well, without the ability to see into those tunnels and see further into the headers, things like RSS, like checksum, like GRO and TSO won't work. The stateless offloads that accelerate the traffic. Without those, you're limited to about 2 or 3 gigs of traffic per core, and sometimes if RSS doesn't work, that's all you get because there's no entropy between the 2 points. So you can't even spread it across multiple cores. So with that, we want to be able to look further into these packets and be able to filter on them and direct them into specific queue regions or queues on the individual controllers. So just a real quick capability level set on the 700 series, the Intel Ethernet 700 series. How many people are familiar with these controllers? The X710, XL710, there's the XXV. The Roman numerals are the port speed. It seems obvious when we put it out there, but it's not so obvious, obviously, when people are like, oh yeah, that's what that means. So anyway, and so that's the first series that has this capability. We had the 500 series, the 82599, the code name was Niantic. A lot of people use that controller. It's also on the X520 adapter. It does not have a lot of these capabilities. So the 700 series is where these things came in. So we can do packet classification. We can look at it from PC types and from packet types. We have 64 packet classifier types, and then we also have 192 packet types that we can put in. Some of these protocols have a dozen different variants within. So you can see we can run out very quickly with that number. Future controllers will have more, but this is what we have for today. And then we have the ability to do packet steering and mirroring of tunnels. And then we have our hashing for like RSS, and then exact flow matches with through Intel Ethernet Flow Director. So that's kind of a high-level summary. And this is what the packet processing pipeline looks like on the 700 series. So first thing it goes into is the packet buffer and then into the parser. And the parser goes through the header, starts looking at it, says, okay, that's the L2, L3, L4. But the key is each time it goes, it has to know what the next protocol could be as it goes through the parse graph. So if it says, oh, that's an L2, next one's going to be L3, it has TCP, UDP, and then I have no idea what that is, it will say that's an L3 payload. And that's all it can see. So then it kind of drops out and forwards the packet on. So if the next protocol isn't defined, that's as far into the packet as you can see. So in that case, if if you send in an IPsec, says that's an L2 payload. Not much entropy if it's coming all from one server, right? Because you just got your max. That's it. So as we're going through and going down through the parse graph, we're able to fill in what's called the field vectors. So that's the field extractor. And it starts putting in, here's source MAC, destination MAC, IP, source destination, source port destination, and goes through and starts populating this field vector. And that is what we use to do filtering on. That's how we do RSS or flow director. So the more information we can get into that field vector, the more we can do with the packet before sending it up to the operating system. And the more information we can provide the operating system or the stack. Okay? So then the next step is that classifier. Then it goes in, and as I said, the more information we have in the field vector, the more we can do in the classifiers, and then out and sends it up into the OS. Does it make sense? Okay. Is everybody familiar with this concept? I figure with DPDK, people would be familiar with this. I talk to the enterprise guys, and they're like, I have no idea what you're talking about. So, just wanted to do that. So, what is dynamic device personalization? It's two parts. What was that? Is that one? Is that better? Or is that? I need to be turned up. Is that better? Oh, hey, I can hear myself.
There we go.
That's a little bit better, huh? Okay. So with dynamic device personalization, it's two parts. One is being able to add new protocols into the parse graph and into the into the parser, and that gives us a wide range of capabilities that the default firmware doesn't have, because now we can add in like GTP, PPPoE, new protocols that haven't been the spec hasn't been ratified. There's a lot of new stuff going around, VXLAN GPE. Those new ones we can now add in as a known protocol. We can modify existing. So we have VXLAN GPE support for NSH headers, but there are additional for GTP that are going to be added, or that are being added into the specification. So we can add those in. Now we have a limited space to work with. So that's one reason why we have this, why it's called dynamic, is that we can add and remove these protocols out of the default firmware without having to reload the driver. In a lot of cases, you can just add them on the fly. Now, don't recommend doing that in a production environment without stopping traffic, because as it goes through the parse graph, you could lose packets. But if that's not an issue, you can apply these on the fly, change them without having to take the device down or stop traffic at all. We can also disable some smarts. We can make a smart NIC dumb and say, no, you no longer know how to do IPv4 or IPv6 at the hardware level. So there are some companies that are using that type of capability as well, as being able to modify existing or disabling existing protocols. And for debug, works great. This is one thing that we do in our labs, is we try different things. We look at how we can do hashing differently or filtering differently, and using, adding additional information into the descriptors and so forth to be able to try to optimize specific types of workloads. Now the second part is with the switch, is configuring this switch classifier. And that's actually something we have across the board today on our NIC. You can actually go in and modify how those packets are filtered, how they're classified, and how they're directed. So the second part of this is something that was there. The first part was there, but you had to reload the firmware in order to get the new protocols, which required a reboot of the server, which is not really acceptable. It's not ideal, but it's not even acceptable in a lot of cases, is having to completely reboot in order to add functionality in. And so that's why we added this first part. So how do we load this, and what are these profiles? So
You specified about something like a dumb NIC. I didn't get that.
the dumb NIC?
NIC, yeah.
So we can disable, so the question is about the dumb NIC. How do we make a smart NIC dumb? we can disable protocols. So we can, in that parse graph, we can say, if you see IPv4, stop classification. You could just kill it, right? You can actually stop processing it and drop it, or just not go any further with it. So there's certain things that we can do with that. So we can take functionality away as well as add it. Okay, so how this works is you have our default firmware, which is the 6.01 firmware, which was released about mid-year last year. And once you have that, then you have this capability along with, that's now built into DPDK. Where do you get the profiles? Well, the profiles are developed by Intel for this generation of products. Yeah, make sure you turn off your cell phones. So you work with us, and we can create a profile. So we have a list of them, I'll show you, of ones that we're developing, but we'll put them out and work with customers under NDA because they haven't been fully validated. So work through one of your Intel contacts, and we can provide the profiles before they're released. And then we create this package. You can then load it with DPDK. We have the API. We also have it built into TestPMD. So and I'll show you that in the demo here. And then you can take advantage of it. And you can take advantage of the new functionality. So, and that may be modifying existing protocols and field vectors. We can do that. We modify a lot of different things or add new functionality. Working with a group for radio over Ethernet, different custom tunnels that some of the cloud vendors have are using. Added quick protocol support. So there's a lot of different things that we have available on that. So what does this do? As I was explaining, by default, the firmware 6 can only see so far into, in this example, the GTP traffic. Okay, so it can get into the UDP, and then it basically doesn't know what the next protocol is in the parse graph. So it says L3 or L4 payload, depending on how far it made it down. And that's it. Well, if the traffic is tunneled and it's coming from one server to another, MACs, source and destination are going to be the same. IPs are going to be the same. Source port, or the destination port is going to be the same. Source port may or may not be the same, but that's it. The rest of it is all, they're all the same, and that's all we have. Entropy is not going to allow RSS to spread that traffic across cores. Now, once we add the protocol support, now we can see further in, and you can then take advantage of all the green areas on the header. Okay? So, we're going to try something a little risky. So this is a live demo. I'm connected back into Jones Farm up in Oregon, where my office is. And so what we have on this side here is we're going to have traffic coming in. These are the protocols that we're going to generate. So I'll start the traffic up. There it is. And you can see I've got IPv6, IPv4, UDP, and IPv4 SCTP. But I said I was sending all that other traffic. But that's all you can see on most NICs. Most of these protocols aren't supported by default on network adapters. Okay? So first thing I'm going to do is now I'm going to apply the profile. So now the 700 series can now see further into the packet, and that was while traffic was going. As I said, I wouldn't necessarily recommend that in a production environment, but you can see it does work. And you can see that the traffic is now being being received and classified and spread across all 16 queues that I have on this one. Okay, and that's what all the different colors are. But that's not really that effective because I'm kind of shotgunning it across multiple cores, and I may not want that level of traffic to be spread out like that. So now I can assign queue regions and TC classes to the different traffic types. And so now I set up one queue for standard UDP IPv4, one queue for IPv6, and you can see it listed up there. And then GTPU, both IPv6 and IPv4, UDP and TCP, are set up on the upper queues here. Now I haven't used all the queues within the queue region that I defined, because I may want to keep that down so I don't end up using and wasting cores. Now I don't have a lot of traffic. There's only 1 million packets per second per protocol there, but it's just as an example. But if I had more coming in and I needed additional capabilities, I could grow the number of queues per queue region per protocol. And so now, taking advantage of all 16, now I could, on this NIC here, we have 48 physical cores, so I could take advantage of all 48 queues and separate that up into and powers of 2, so 2, 4, 8. You guys know how to do the math. So, but I can create those queue regions with that number of queues. So if you have specific types of traffic that you want to be able to have more bandwidth on, you can now get down to, limiting or consolidating traffic of different types onto the same queue region. So you could set up all of IPv6 on one queue region of 2 queues, because, or control plane traffic all onto that one queue set or queue region. Does that make sense? Yes. Do you have a microphone? I think that was part of the housekeeping. Yes. I got to make an example of Intel people.
Can we use these queues to implement scheduling, QoS kind of?
Yes. Yeah, there are additional things. So anything you can do with queues normally within DPDK, you can do on top of this. So this is just adding the ability underneath that we can now see these different types of protocols. So you can do, and that's that second part of DDP. And I don't use the acronym because it means way too many different things. The classification, we can do a lot without having to apply a new profile. So using the existing protocols, we can do a lot of the QoS and so forth already. And so you can do a lot of this without applying a new profile. It's just part of the queue region. And that's basically what I do in the demo, is I start out by applying the profile and then configuring and assigning each traffic class to a queue region, and each protocol to a traffic class, and then assigning the queue region to that traffic class, or vice versa on that. So yeah, we can do this already, and then you can do a lot of different things. On the transmit side, we do have transmit rate limiting. Receive, not so much. We don't have a receive limiter, but you could limit the amount of processing capability And that's one way of doing receive limiting, is you give it one core or one queue. You can stack stuff up, all your control plane, if that is low bandwidth, low processing, you can put that onto a single queue. So I put all of my ARP and LDP and SCTP, all that stuff, all onto one queue, so I don't have that random information, all that, the spanning tree and all that stuff, interrupting cores that are doing work. So then I can assign all that control plane processing up into a core that, in a queue that is kind of standalone. So I don't have to worry about that interrupting what I'm doing on the actual, customer data and so forth.
Is the RSS application lossless?
Is RSS lossless?
When you configure.
So yeah, RSS is not, but the traffic classes, you can set priorities up and have them lossless or lossy. So there are some capabilities that you can do on at that level as well.
Does it have the capability to dynamically reassign these queues, meaning that when you see traffic of certain class requires much more queues, that you basically can take off some of them?
So technically, yes. Goes back to removing queues can cause problems, because if traffic isn't, if it flows in flight and then it gets moved over a different core, that can cause packet loss. And then the same thing, adding, if you have to be careful doing it, because you could end up having, out of order, and you have to work within your own environment to see if that's feasible, is the short answer. Because yes, it's possible. Whether or not it's something you should do, we kind of leave that up to the individual, up to each individual system. Now how I did this, let's see if I, so I just rolled back the RSS. I'll put it back to. So how I get around this is I assign, or I block out the queue region and say I want to basically have 4. I want to start the next one up 4, but I only actually enable 2 of the 4 in this case. I could have this as 16 and then start my next queue region at 16 above that, but still only enable 2. You just have to kind of plan ahead on that, but it is in powers of 2. So you get it looks really bad on a screen, so that's why I stayed at 16. It's really hard to get that many queues showing up on a demo. So if you go 8 or then 16, you can run out of cores really quickly, because the next step's 32. So so that you have to kind of be careful on that side. But yeah, it is. You can do it dynamically, as I just did, but you could be dropping packets, and that may not be acceptable in the environment. Yeah.
We have actually P up and V up actually, and there is a SRI only in between. So this is done at each V up level.
You can, yes, we can. So we can create queue regions and route into specific VFs. In addition, I have set up where we routed traffic into specific VNFs based on this. Yeah, you can do that as well. Now, one thing to note: these are per device, so per adapter. So if you have 1 port, 4 ports, all the ports have that. They share this protocol table. So and that's. Go ahead.
But each port may be having maybe say 16 VFs or. 32 years or whatever.
Yeah, but you can, so the protocol side of it, the package, the profile is at a device level. There, you can filter at a per VF and PF standpoint. So that second part of this is on a per port and per VF, PF. But the package level, so the parse graph itself is a shared resource, is part of the shared resource of the part itself. So once you define it, you just have to load the metadata up on the second port. The profile is already there, but it will do stuff, but it won't know that it's GTP. It will say reserved. I know it's something different, but it's not in the metadata table. So you just load that metadata and it comes up.
So are you saying it can be done at both PF level as well as VF?
Yes. Now the profiles are applied on using a DPDK enabled PF. So you have to be running DPDK on the PF. A VF cannot push this, right? And it has to be done currently through a DPDK PF. We've got one more question here. Let me jump back to the presentation. So I did include some of the screenshots of that demo in the slides. I just skipped over them. Go ahead.
So assuming VFs aren't in use, is it possible to configure this on the NIC's VEB on a per viewport basis so that you have post-mediated I/O, but it's isolated on a set of queues on that viewport on behalf of the guest?
Yes. I'm trying to follow it. Yes, I believe that's, I believe I got that flow, but yes.
So all the guests can have different settings and properties in terms of how the traffic
Yes.
is routed.
Yeah, and you can there are ways of routing the traffic into specific VSIs is basically what it comes down to, is that we can route it into a specific VSI. Currently DPD, and this is something we're working on, currently DPDK can't enable multiple VSIs on the same physical port, but we're working on that. So it's part of the ADQ project that we're working on. So you'll be able to then route it into a specific VSI. So yes, I'm just trying to think through whether or not it's 100% there. I believe that your question is. Okay. I got about 10 minutes. Any other questions? Okay.
How does this work with, suppose I have this SDN controller, SDN controller? So how does it work along with this?
That's what you guys are here for. Part of the software enabling. We're getting the hardware side of it enabled. We're working with OSVs to be able to push a profile down when you push a VNF down, to push a profile down. Now, there's some additional coordination that needs to happen because you kind of need I mean, it is per device, so you have to have some more visibility into how the system is configured. If you have multiple VNFs, which we recommend only one profile per device. We actually have it kind of locked down. There are certain ones that we can, if it doesn't affect the parse graph, we can apply multiple profiles as long as it doesn't modify the parse graph. But only one parse graph modifying profile at a time per device. So that's the piece that we're working. We have some customers that are working with that, but it's not. They haven't open sourced their work yet. But that's why we're bringing it up here. There's a lot of capability, and as we come out with new adapters that have similar capabilities, this is something we want to be able to do is coordinate with the Mano layer to push down and optimize where it's needed. In some cases, if the packet throughput is not that high, you don't have to add this. So you can make, you can have some intelligence in when you're going to add it and when it makes sense and when it may not. You may not get much of a benefit. But one of the things, I don't have it in here, but one of the first packages or profiles that we loaded was MPLS over GRE. And we get about 8 million packets without the profile, and just adding the profile, we were able to jump it up to 32 million. So it can make a significant difference in that environment. It did. In other environments, it may not make, it may not be a packet throughput, or it may not increase the number of packets, but it allows you to direct them into the application and say, these queues will only have this traffic coming in. And so then the application can be more effective and more efficient. So there are a lot of different performance improvements that we can wrap around this, efficiency and even additional intelligence that we can get into the hardware. So these are the commands that are built into Test PMD that allow you to get the list of profiles that are loaded and how you add and remove them. Currently, the GTP profile is going through our fuzz validation tests. Found an error in the test, not in the package itself, but in the test package. We're working with the test vendor to get that addressed. So if you want to test drive GTP or any of the other profiles, please get a hold of your Intel person, they'll get a hold of us, and we can give you access through the NDA site on that. Legal won't allow us to publicly release them, even as engineering samples, until they make it through this fuzz test, because it is modifying the parse graph. And we want to make sure that it doesn't break anything that people are using. Okay? These are the calls that are actually in the APIs. I just put these here, so if you are writing apps. As far as the different protocols, as I mentioned, MPLS over GRE and also UDP, we have those packages, PPPoE, GTP. One that's not up there right now is Quick. We have that one. We have some L2s. We keep adding proof of concepts to these. So if there's something specific that you're interested in, that you have a performance issue with a certain type of protocol, you want to be able to do something with your application, get a hold of the Intel people, and we can work with you on creating a prototype so you can at least test it. And that's the beauty of this, is that we don't have to take 6 to 12 months or 18 months to validate a whole firmware package to roll this out to find out that it doesn't work right in that environment. It may do what we want it, but it may not have any value. So we can quickly, it takes us a day sometimes or less to create one of these profiles. The validation can take a while. Okay? So this is kind of the second part of that first slide, where we had all the orange and red protocols. We can add all these now, and you saw the kind of control we can do once we get these protocols added. These are all the adapters that currently support it. We call this the 700 series. There is one note. We have the X722, which is part of the, I don't even know, the V5, Xeon V5, the Pearly Skylake servers. So it was the Lewisburg chipset was the code name. So the C620 chipset. That we have not enabled this on, even though it's part of the 700 series, because it is a LOM in the chipset. We don't really think people are going to use that for high packet processing and this type of workload. And two, I'd rather not mess with your management controllers and so forth, because we can, the Mac side we can mess with, but we don't know what PHYs are on there, because it could be 1 gig PHYs, 10 gig, so we're not enabling that at this time. Okay? We do have, and you'll see this, DPDK for Windows. We had profiles that we generated for that to show the quick protocol on that. We have them for Linux, and we're working with other OSVs to enable this on their hypervisors as well. That might narrow that down. And there's an article up on the Intel Developer Zone that goes into even more detail than what I just went into. Andre Chilikin and I wrote that. And it has sample code and stuff. And that's where the GTP profile will be posted. You'll be able to download it off that eventually, as soon as we get that test fixed. Because we know the package is good, just got to hit the test to say it is as well. So we're still waiting on that to go through, but it will be posted there. As I said, let us know if you want to play with this, and GTP is the one that we have up on the site, but there are other ones that we're working with as well. And that's it. Any other questions?
Yeah, so thanks for the presentation. One question about these profiles. So I have two questions. One is the plan for the future. Do you expect to have these profiles loaded by default to these devices? And second is, what's the drawback? Is there any jitter, latency, or performance hit due to these profiles?
So as far as our roadmap and whether or not they'll be loaded by default, we have limited resources on the 700 series to add all these different profiles. So no, we don't plan on adding any additional by default. There are a couple that we're looking at maybe modifying a little bit, but the problem is once they go into our firmware, we can't make changes, because if somebody's using it, it's done. You know, we can't change it. So we have a spot that is blocked out. It's reserved for DDP that we're not allowing to be used by anything other. So I have enough to be able to add and remove these profiles, and I think that's a better solution for the 700 series. For the next generations, we will add additional, and a lot of these in by default. Some of them actually may conflict with each other. And so those are the ones that we'll be adding in through this profile method. Especially the ones that, you know, or anything that's custom, right? We just have to be careful with defining something and then having it change, and having one application in DPDK expecting it to be one way, and the other app changed it. So we have to be careful on that, and that's one of the reasons why we're kind of rolling this out slow, is to work with the industry on understanding that, you know, if you write an app to take advantage of this, you got to make sure you know what other apps, you know, and that the Mano layer knows what other apps are running in the VMs in specific, because you are changing the characteristics of the device itself. And, you know, so we've got to make sure. And when you apply the profile, you can see some, you know, you're changing the parse graph. So, and if you're changing the RSS, you know, the queue regions and stuff, you can see some out of order, some packet drop, just because a flow was going one way and then we reroute it. And if the application doesn't understand that, there can be some issues. That's why I said it has to be, you really have to work within your environment to see if adding and, you know, removing it is going to be an issue.
The question will be maybe also for the RX descriptors. Do you have to increase these RX descriptors, especially on this XL710 and 700 series? You know, you need to have a big RX descriptor. Do you need to play with that also?
It's all being handled through, in this case, in DPDK, we can modify through, I think it's through RTE flow.
Okay.
Yeah.
Thanks.
And I'll be here, I think my shuttle picks me up around 6 o'clock, so I'll be here until then, if you have any other questions. Okay? Thank you. I get it.
So, a lot of you have come here before. So let's see.
Well, there are 2 of them.
Yeah, one's for the camera, one's for the room. Okay, you're on.
Okay. All right. Great. Okay.
7? I think it's
I'm using traffic classes as an easy way to implement. So you can run into the other side, and you have TC on top of it. Nighttime. I'll have to. No, I think they'll make it available. Yes.
Plug this in. It's gonna.
Who traveled the farthest? Seattle. Okay. Farther than Seattle? Northerners.
Okay. All right. Never know what's going to happen when this goes in. All right. But I have this cool plug-in.
There we go.
It's coming up. Very nice.
So, detect, right? You working?
Yeah, you should just be able to present.
Okay. All right. It's
Because I think it's just a duplicate screen.
April meetup, 5G. We don't have our mind, but it'll be a good time.
Well, Sanjay is still looking up. Be on the lookout for our April meetup. Topics are machine learning, 5G, and zero-touch automation. Agenda is still being built. And we have a webinar also coming up, right?
We have a webinar coming up, in fact. Mark, what month is it?
That's
Yes.
March 28th.
Yes, we have, in fact, Brian, who you just heard,
Yeah,
is going to be
Brian.
doing a webinar in March.
Yeah. Probably for this audience. if you
Yes.
want.
And in April, we also have on April 25th about the Katie's.
Yes, that's in London.
She's also doing a webinar.
April 16th.
Yeah, there's also
April
a
16th.
webinar on the 25th.
Yeah. Oh, by the way, I'm I don't know from 6 Wind if anybody's interested to go to London.
Always.
Always, yeah, okay. So we can send you the information. Yeah. And then who's going to be at ONS next week? Okay. Yeah. So we have a workshop on Kata containers on Tuesday on the ONS. And we have a session on 5G and packet processing on Thursday. So we will look out for that. Okay.
He's mic'd, so
I think I.
go ahead and
Hello?
start. Yeah.
Yeah, all right.
Yeah, so Sanjay,
Yes.
take it away and let you introduce yourself.
Okay. All right. Thank you. Thank you, everyone, for coming. And sorry for the slight delay in starting. My name's Sanjay Igari. I'm Senior Solutions Architect at Red Hat, and I am on our Telco and NFV team. What I do is I look at our telco initiatives across our global telco customers. And what we're trying to do across the telco customers is help them adopt increasingly open source technologies. And I think, as you've seen, there's more and more of that going on in the industry and the move away from proprietary systems. What we want to talk about today is specifically service assurance and the work that we're doing as a community in OPNFV, projects like Barometer, but also not just in the project, but also how that impacts telcos and what they are trying to achieve. So my perspective is going to be a little bit beyond, maybe a little bit higher level in terms of going beyond the project itself, but more in terms of use cases and what our customers want to achieve with the technology. My background, I've previously been at VMware and Cisco, a networking background, been at a startup, an OpenStack startup before, like many of you probably. So a lot of time in the industry. I'll also be at ONS next week, so like probably a lot of you. So anyway, let's get started with what we're trying to do in service assurance and what's going on. I think we all know that telcos are changing from sort of the old way of doing things to the new way. If you think about the old way of doing things, they would just go to one vendor and say, we're going to penalize you if you can't meet the SLA. And if any of you have sort of been in the industry, you may have seen that. There were monetary penalties for not meeting something. So they didn't look at the technology. They just looked at, well, we're going to charge you if you don't meet this. So that's kind of that doesn't really help, right? It's just a punishment, right? So that's kind of the old way. So what we like to think of is there's a change in culture that has to happen. So it's just, it's a boilerplate slide we have I put in for that purpose. But let's now look at, what I want to show you is, for a lot of people who are in the enterprise world, they may not have seen the complexity that telcos have to deal with. So I like to pop up something about, this is what telcos need to look at and are trying to deal with in terms of service assurance. So telcos it's not one data center. And it's not like 3 or 4 data centers. It's thousands of micro data centers. And this changes the model when you want to say, how well is my network operating? Because where is the network? Where are you gathering that data from? You're gathering it from a lot of places. So what happens is, all of a sudden, the old way of getting metrics, or the traditional way of getting metrics, doesn't quite work. The way that they've traditionally done it, polling every device in the network and logging in and saying, okay, show interface. Let's see, what are the packet counts? Show interface. And let's log into the next device, show interface. Let me look at that. Well, if you've got to do that across all these different sites, you're going to get out of sync very, very quickly, because by the time you get to, the 300th site or whatever, you're kind of way out of sync with when you started. So that doesn't quite work. And what you really need to look at is a more event-driven model, where when something happens, it gets pushed back. And you start getting pushed events that happen in the network, as opposed to going out and trying to find out what's happening. The other benefit of that is, of course, you reduce your CPU usage, because you don't have a bunch of servers that are going out and just cranking out. All they're doing is polling everything in the network, right? So you get better utilization across your infrastructure. So additionally, you have a way to normalize all the different types of devices that you've got out there. Because the reality is, what you've got out at radio sites is going to look very different from what you've got in your core data center. Those devices out here are going to run more power efficient chips. They may have different software running out here that looks different, but what you want is some type of common metrics, or common metric format at least, that comes back. So what we like to think of is, it's not just about having a common NFVI layer, and that's what the industry has concentrated on so far, but what we'd like to have is, can we build sort of a common automation engine and a common messaging layer across, so that we get not just flexibility, but compatibility and scalability. That's what's going to enable us to get analytics across all of these areas. The radio, the central office sites, as well as the core data centers. So I talked about moving to sort of a decentralized event-based model. This is something that's been researched years ago. It's now sort of moving into production, or at least thought of, telcos are thinking about putting these types of things into production. And I think we're seeing that in the open source world as well. And I'll talk about some of the collect-D work and how that fits in under OPNFV, and where that fits in sort of in the overall framework of how we might deliver that to telcos. But before we get there, You know, I spend a lot of time with the large telcos, and I thought it might be instructive to talk a little bit about what's the end game. You know, what if you were to ask them what they really want, then that might help us keep in the back of our mind where we want to get to, because you know, otherwise we're just building stuff and not knowing what they really want. So it's not like we're going to get there in a day or a year, right? But let's just keep in mind what they really want. So I built something, a slide that shows if you were to ask them what they really want, what would they want? Well, what they really want is they want to be able to integrate not just their servers, but actually their servers, their network functions, and their physical functions, as well as even their customer interfaces and the logical services they built on top of them. They want to integrate all of these parts of their stack. This is sort of the telco stack, if you were to see it. And they actually, and then you start talking to them more, and they say, well, I actually want to do analytics across the whole thing. You know, say, oh, well, that's complicated, because the reality is all of these things have their own ways of communicating. Even within, we all know that within VNFs, they all talk differently. Within service assurance, they all talk differently. I'm going to show you how, you know, even within service assurance, there's no real standards, right? They all talk differently, and we're trying to work on that. So this is kind of a long-term goal, but we can slowly get there. And then they say, well, we want to actually bring in the smart devices and IoT into there, and we want to bring in, artificial intelligence across this whole thing. Okay, great, you know. But I think it's instructive to think about the fact, out of this whole thing, it's instructive to think about the fact that they do want some type of cross-layer communication. So if, you know, to the extent that in the service assurance community, we can get information out of, say, VNFs or out of physical network devices, that's a good thing, not a bad thing, okay? And I think that's the point to get out of this. So let's focus in, for now, on service assurance itself. If we can't make this successful, then the rest of the diagram is sort of meaningless, because when it comes down to it, operations teams aren't going to let something go to production without a way to measure service assurance, and that's why we're doing this. So when we talk about the barometer project, I mean, this is shamelessly stolen Intel slide. So this is actually barometer project is really about being able to monitor your infrastructure, do analytics on it. And the problem is a lot of these components traditionally have had their own APIs, and they talk differently, and they have their own ways of communicating. So if you try to build an integration, there was always this n-squared problem of, I can build an integration between A and B, and someone else can build an integration between C and D. And the customer goes and selects a bunch of different components, and there's no integration. So someone else has to build yet another integration, and then it just becomes sort of a nightmare. And so the CollectD project is a project that is trying to bring together, through a plug-in model, all of these mechanisms of communicating, so that you can have sort of input methods and output methods, and then you can select how do I gather information? How do I publish information? And so that way you don't have all these problems of integration, or you can reduce that problem space massively. one example that was actually shown a demo was done in the Beijing conference was on monitoring residential services, and so this was done via a broadband network gateway, and so Collect-D was used to monitor these F5 instances and the BNG instances and gather some data on that. And so the idea was, okay, if we can gather telemetry from these instances, we can monitor how well they're operating. And if you can monitor how well they're operating, you can actually determine even before something goes wrong that something's out of whack. This is the ideal goal of operations teams. That's what they really want to do. They want to identify before something goes wrong that something's just not right and take action so that the network doesn't go down. So as I was saying, what exactly is Collect-D? It's a way of normalizing essentially the way of collecting and publishing data so that you don't have to have these massive number of integrations of input and output. And so this has been a project that's where it's been going on for some time, and a lot of work's gone into it. There are like an enormous number of plugins for this that under the Barometer project, we're able to, there's a lot of initiatives for supporting it. Now, the question becomes, though, as I said, what does it do? Like, what does it do beyond what's already there, or what telcos are already doing? Like, one of the things I like to talk about with the customers is, okay, you're already monitoring your infrastructure with existing network management tools, but when you virtualize your networking functions, you're introducing some extra things that you need to monitor. You need to monitor your servers. You need to monitor your storage on which these virtual network functions are running. And if you just run the existing monitoring software that you already have, you're not monitoring those things, because all you're monitoring are the networking functions, because you've taken software that's running on a network device and virtualized it. So all it's doing is monitoring what it used to monitor. And you're not monitoring the underlying infrastructure. So that's really where this comes in. You can actually you can monitor other things that are now new that are coming into the infrastructure. So as I said, well, open source is great. There are a lot of plugins. I mean, this is all I could fit on the screen, by the way. There's actually more. So, but one of the things that we run into in open source, of course, is as a community, it's great to have this massive amount of choice. As a customer, it gets difficult because how do you make the decision of, wow, I can select all this stuff, but what do I select? Can someone help me select? And this starts to become this question, because they start to see consulting dollars start to come out of their pockets, right? Because, oh shoot, I mean, I don't know what to select, right? I mean, there's a lot of stuff there. So they start to want some type of package around this whole thing. And so it's a great opportunity, I think, for to come out of the community. You know, there's opportunities for companies to start packaging these things up, and certainly at Red Hat we also are looking at, you know, how do we package some of this up and have options. But it's not, you know, there'll be lots of opportunity to package these up, make some choices, offer options for, you know, this is where, here's one way, here's some inputs, here's some outputs that we can support. So I'll show you one option for that coming up, which is, you know, is sort of being worked on, but is not, you know, is still sort of upstream or in process of upstream, to sort of that kind of thing. You know, one option for this is to kind of choose a publishing mechanism. If you were to choose the publishing mechanism and say, okay, gather your metrics, but if you have one type of publishing mechanism, at least now you can, now anyone who wants to collect information knows what they have to subscribe to. They don't have an infinite number of different subscription mechanisms, right? So that's one way to sort of constrain the problem. So this is one idea that we're looking at, and the advantage of that is you can now have third-party integrations that don't have an infinite number of different ways to that they have to support to plug into this. The other advantage is, of course, you know, plugging into other industry initiatives like ONAP becomes simpler, and things like that, which is also going to be, of course, very, very important. And you can still, of course, support the integrations with standard event-driven, standard metrics databases, et cetera, such as Prometheus. So if we look at use cases around this, I wanted to sort of talk a little bit about telco use cases, like why they want this type beyond just the operations team saying, I want to monitor, right? Like what benefit from a business perspective does it give them? And one of the real problems that I've seen in the field that telcos are constantly struggling with is something that I think we've all experienced ourselves. Go to any concert or stadium or conference and try to use your phone for data. And you look at it and you'll see a signal strength. Hey, I got 4 bars or 5 bars, but it's not working. You're not getting any email or you're not connecting. Why is that? Why are you getting signal strength, but it's not working? Well, there's signal strength, so there's plenty of spectrum. It's not a spectrum problem. I mean, everyone says, oh, there's a spectrum problem. There's not a spectrum problem, actually. It's actually because the PDN gateway between the mobile phone network and the internet is overloaded. Because when the cell phone network was designed, it was thought that the internet was just this plaything, this separate thing, right? That, some people might use the internet, but most people will use telco services. You know, of course, didn't turn out that way, right? nobody really uses telco services and everyone uses the internet. So everyone has to go through this gateway and it gets overloaded. So what we need today is to scale out these gateways. But these gateways are expensive because they're hardware. So, well, why can't we do dynamic scaling and scale them with cloud-based? They're basically routers, so we could just do software routers, right? We could, and provide them from the cloud. They might have higher latency, but they should work, right? But that requires gathering metrics, triggering an automated spin up of an instance of a router, and identifying when they're needed, doing some reconfig or registration of those routers so that they start working, right? Whoever can do this will actually solve a real world problem and actually make lots of people really happy, right? And make those telcos actually be able to advertise, hey, we work even in these crowded areas. And when you next time you go to a conference, you can say, hey, I have this guy's service, it works. You'll be the only one who has service, right? So, I mean, think about that. It's a real world problem that can be solved by these technologies. So, and everyone who I've talked to about this problem says that, yeah, they really want to solve it. So with that, I'll say thank you, and I'm happy to answer any questions if we have time, or anything else.
I'm KRS Murthy. When you have both, whether it's a telecoms version of it or the data center version that you cover, assuming that you are using software-based storage, software-defined networking, open flow, etc. Even otherwise, there are some who have implemented, some who have not implemented. How do you handle service assurance when it comes to east-west traffic compared to north-south traffic? Because they're separated by distance a lot of times, a lot of transit delays are there. How are you going to make sure the latency issues are handled? And anything that you do in general will not know each traffic, which is east-west, which is south, because it's not monitored by, at that level. How are you normally doing in Red Hat or in general, technology-wise?
Yeah, well, I think when so if you think about the east-west versus north-south problem, I mean, I think you should think about it where east-west in the data center, I mean, there are two ways to think about east-west. I mean, some people think about, I mean, east-west can sometimes be a hard problem if you try to stretch your layer 2.
Yeah.
I don't think stretching layer 2 is a good idea. So I believe you should keep the layer 2 within the data center. If you keep the layer 2 within the data center, then east-west isn't a problem, because it's just, then your latency is low. So then it's not a problem. So then, to me, maybe that avoids the problem, but I say it's just the wrong thing to do in the first place, to stretch the VLAN.
One more.
Yeah.
You didn't talk about any instrumentation, IoT in the network. And probably that was not the scope of the talk.
Right.
If you add all of that, whether it is a 5G network, monitoring the battery, if you say acid battery, the modern lithium based battery, any thoughts on how you do? Because IoT will be supposed to be there everywhere, and actuators will be there. If it's an environment, and then if you are also dealing with autonomous vehicles, and autonomous drones, autonomous cars, etc., buses and trucks, if it's practical, you can talk about it now, or we can talk offline.
Yeah, well, to deal with it quickly online, I'll say that network slicing is going to be a key part of that in 5G. Because you're going to have a different network slice to deal with those topics. And to go and, I mean, I could talk to you offline more about that, but you will need network slicing to carve off a separate piece for those.
You have any best practices, particularly the 2 points that you mentioned, a multi-vendor VNR environment, and then also mentioned about band burst routing. So the 4th point, the cloud-based model leads the burst routing capacity. Have you done any kind of best practices towards the delivery of burst routing over the WAN?
So what we are concentrating on creating the infrastructure for this and leaving the actual, like, best practices for a given router is best done by the router vendor, right? Not by Red Hat. So, I mean, you know, and quite frankly, the customer is going to trust the router vendor more than Red Hat. Okay, but we're there to just make sure the platform is going to handle it properly and to give the infrastructure so that you can gather the appropriate metrics so that you can do that. Because if you can't gather the metrics, then you have a problem, right?
Any more questions? Thank you, Sanjay.
You're welcome.
So now we have a break. We're going to go into breakout sessions. There's going to be a DPDK track and there's going to be hands-on lab. One is on security, other one is on STO. So these rooms will be configured into 3 rooms to accommodate the breakout. There is some snacks and soft drinks available outside. So please feel free to take that and also use this time to interact with Sanjay and Brian and also among each other. Thank you. So see you.